accuracy has to do with whether or not your experiment, the number that you get from your experiment, is close to the true value. Okay, so somewhere out there in Earth, someone was able to simulate the combustion reaction properly in a really enclosed space where no heat is getting lost to the air and things like that, and everything's going to your thermometer. They have the true value of what it's going to be. And if your experiment matches that true value, then your experiment is accurate. So you know a number what it's supposed to be. Your teacher's going to tell you what it is, or they might tell you at the end if they don't want to tell you at the start. If your number is close to that, then your experiment is accurate. If it's not close to that, then it's not accurate. Okay. The reason enthalpy calculation experiments tend to be inaccurate is because you're not usually able to measure all of the heat. Okay. Because when you're calculating enthalpy, it has to do with Q, right? Q on N, which is heat, okay? Heat per mole. So if your experiment's not accurate, it tends to be because you're not able to measure all of the heat. So for you to minimize the heat loss, what you want to do, there's a few different things that you can do. For you to minimize the heat loss, this is something you'll get asked of in exams as well, by the way. So in terms of questions to expect, your calculation questions that we just did, as well as questions asking you how to improve the enthalpy experiment. Okay, that could be enthalpy of neutralization, that could be enthalpy of combustion, but the same theory applies, yeah? If you want to minimize your heat loss, you want to decrease the distance between your flame, your spirit burner flame, and your beaker. What that means is there's a smaller distance for your heat to travel to the sides, so more of it's going to get captured by your beaker, okay? Which means your thermometer captures a higher temperature increase that can contribute to calculating Q, and it means you get a bigger Q value and your enthalpy value is closer to your true value. You guys give me a thumbs up if that makes sense. If you decrease the distance, the chances are you're going to capture more of that heat, okay? So let's say, for example, if someone's trying to throw you something, if you're really far away from them, the chances that it's going to go to the left and right of you is really high because you're so far away. But if you're much closer to them, like literally right here, the chances of you catching it just by spreading out your arms is much bigger. Okay, so you want to decrease the distance so that the space that something can travel to is smaller, so that your chance of capturing it is greater. You also can minimize your heat loss by making sure that there's nothing that's trying to carry it away. Okay, so you want to, it's really technical, eliminate sources of air current. What that really means is make sure that there's no wind blowing on your beaker. Okay, so close your windows in your school lab, put something that we call just a shield, pretty much. A wind shield is what we call it. Like, put a windshield around your around your spirit burner, so that even though air is going through, it's going to hit the windshield and deflect instead of going through to your spirit burner, which means, once again, it goes up instead of getting carried away by the wind, and then your thermometer can capture a greater increase. Or you can also make sure that no heat gets lost from your beaker as you're doing the experiment. So even if heat is going to your beaker can release some of that heat. What you want is you might use some insulating material as well. Okay, so instead of using a beaker, you might wrap it around with some styrofoam, something like that. Or you might wrap it around with, styrofoam, which is polystyrene. Okay. Or lastly, the chance of you doing this in a school lab is very minimal, but you can also just prevent incomplete combustion, which means you want to increase the amount of oxygen that you supply to your spirit burner. So more of your spirit burner can actually fully turn into carbon dioxide and water instead of just stopping at your soot or your carbon monoxide stage. Okay, so can you guys give me a thumbs up if these make sense to you? Normally you want to minimize the heat loss, but that fourth point is about incomplete combustion. So you just want to think of ways to make sure that the heat goes into your beaker and not out to the environment or not out to anything else. So you want more heat getting read by your thermometer.